With you today, but today I'm going to cover the first topic of Chapter 5. This video is available on my website. You can watch it as many times as you want. You can ask your substitute to pause it as many times as you want. It's about 8 to 9 minutes long. Today we begin Chapter 5, and we're going to cover polynomial functions. What we're going to do is classify our polynomials, graph the polynomial functions, and describe end behavior based on turning points and degrees. First, a few definitions. A monomial is a single term. It could be a constant like 6, it could be a 3x squared, or it could be a product xy. A polynomial can be a monomial, one term, or it can be many more terms, such as 3x squared plus x minus 4. Again, you can ask her to pause if you need her to. So these classifications are on page 281 in your textbook, and I do want you to copy these into your notes, but for now I'm going to go through them very quickly. We can name a polynomial by its degree or by the number of terms. There are two ways to classify it. The degree is the power on the x term. So if I had a 0 power, that's x to the 0 power, that's simply 1, and that would leave us with a constant, like 6. And because there's only one term, we'll call this a monomial. If I had a degree of 1, that would be something like x plus 1. That's a linear polynomial. And because there are two terms, x and 1, that makes it a binomial, bi meaning 2. If I had a polynomial of degree 2, that's a quadratic. We spent all of Chapter 4 on quadratics. And so, for instance, I could have x squared plus 2x plus 1. You see, not 1, not 2, but 3 terms. We call that a trinomial, tri for 3. A cubic has a degree of 3, so x cubed minus x squared plus 2x plus 1 is an example of a cubic, and that we call a polynomial of 4 terms. In other words, once we get beyond the number of 3 terms, we simply say a polynomial of that many terms. So you could have 4 terms, 5 terms, and so on. A 4th degree polynomial is a quartic. Quartics look like x to the 4th minus 2x squared. That's binomial because there's 1, 2 terms. And a 5th degree polynomial is a quintic. So negative 3x to the 5th plus x cubed plus 2x minus 4, again, is a polynomial of 1, 2, 3, 4 terms. To put in standard form, we always want to arrange by degree. So you want your highest degree term first. So when I look through this list, I see my highest degree term was 7x to the 5th. That will come first. Going back in the list, I see the next highest power is x to the 4th. So 5x to the 4th is the next degree term. That comes second. Again, going through the list, I see a negative 2x cubed, and that's going to come third. Then I see not 1x squared, but 2x squared terms. Combined, these two make the 4th term. Then I have a 4x. That will be our 5th term. And I have a negative 8 and a positive 3, which together make negative 5. So, if the arrows confuse you, lined up you should have first 7x to the 5th, then 5x to the 4th, then negative 2x cubed, then the 13x squared and the 1x squared make 14x squared, then the 4x and the negative 5. This polynomial is classified as a quintic because the highest power is 5. It's a quintic polynomial of 1, 2, 3, 4, 5, 6 terms. If I were to ask you what is the quartic term, you would say that's 5x to the 4th because the quartic is the 4th power. The cubic term is negative 2x to the 3rd. The quadratic is 14x squared. The linear is 4x, and the constant term is negative 5. So, if I were to ask you to classify these by degree and number of terms, you would first write them in standard form. I see negative 14x cubed is the highest power of x, then 2x squared, and then 6. And because this is a 3rd power, we call it a cubic trinomial, 3 terms. This one is already in standard form. I see my 4th degree, makes it a quartic. And you can see that there's 2 terms, so it's a quartic binomial. And this last one I'm going to rewrite as negative 9x to the 5th plus x to the 4th minus 2x squared plus 3x minus 11. Obviously, there is a fifth power, so that's a quintic. And if I were to count the terms, I would count 1, 2, 3, 4, 5. So it's a quintic polynomial of 5 terms. So you'll be doing this on your homework. Now, we talk about turning points. If n is the degree of the polynomial, that's the highest power of x, then it has at most n minus 1 turning points. So a linear polynomial is a degree of 1. Well, 1 minus 1 is 0. It has 0 turning points, and that makes sense because lines don't turn. A quadratic, however, has a power of 2, but 2 minus 1 is 1. That means it has 1 turning point. Turning points are where it goes from going down to suddenly going up, or going up to suddenly going down. Now, both of these are cubics because I see 2 turning points for both. 1, 2, 1, 2. And of course, if you have 2 turning points, your degree must be 1 more, or 3. End behavior is what does the graph do to the left and the right. So for instance, this side, it goes up left, up right. This one, it goes down left, down right. This one, it goes down left, up right, up left, down right. And you could say, well, how would we predict that without actually graphing? Well, look at this chart right here. This tells you everything. So for an ax to the n polynomial, where a is the coefficient and n is the degree, if your degree is even and your a value is positive, you're going to be up and up, left and right. But if your degree is even and your a value is negative, you're going to be down on the left and down on the right. Now, if n is an odd degree polynomial and a is positive, you'll go down on the left, up on the right. But if n is odd and a is negative, you go up on the left and down on the right. So what I want you to do is take a moment and using these front terms predict whether your polynomial is one of these 4 things. Okay, for this one, you notice it's an odd degree, and you notice that the a value is positive, so you should have picked down and up, down on the left, up on the right. For this one, it's an even degree with a negative a, so it should be down on the left and down on the right. So you get something like this, and something like this. Now, last slide, finding the degree by using the differences. Let's say you have a table of values for a polynomial. Your x and y values are these. What they want you to do is take the difference of the y values. So for instance, negative 7 minus negative 1 is negative 6. Negative 3 minus negative 7 is positive 4. 5 minus negative 3 is 8. 11 minus 5 is 6. 9 minus 11 is negative 2. And negative 7 minus 9 is negative 16. We're looking for a constant in this last column, which we don't have, so we have to find the differences one more time using the new numbers. 4 minus negative 6 is 10, 8 minus 4 is 4, 6 minus 8 is 2, negative 2 minus 6 is negative 8, and 16 minus negative 2 is negative 14. And again, we do not have constant numbers, so we must go once more. 4 minus 10 is negative 6. Negative 2 minus 4 is negative 6. Negative 8 minus negative 2 is negative 6. Negative 14 minus negative 8 is negative 6. And voila! We have a constant. Therefore, it took us 3 differences to find that constant, so our polynomial is a cubic. Your homework is page 285, numbers 15 to 39 and 47 odd. Please get busy now. If you need to, you can rewind this lesson. Thank you.